How's it going, everyone? Today we'll be doing evaluate reverse polish notation. Never done this one, but we'll see how it goes. Let's try it. Okay, so we're going to do evaluate reverse polish notation today. So sounds complex. So let's see how it goes. Usually what I do is I read through the problem, whiteboard it out on the iPad, which I'll also show. If it takes a long time, I'll probably speed it up, but here we go. Okay, so just spent some time on the whiteboard, diagramming it out, going to different sites, right? Understanding what reverse polish notation was. I didn't know what it was. I think it's super cool. You don't have to use parentheses, basically. So the way it's written, it logically kind of will connect together, and we'll learn about it a little bit as well. But hopefully you got to read about what it is and understand the question, because I'm going to dig into the code now and code up what I did on my whiteboard. So here we go. That is correct. Well, okay, wasn't too bad. Okay, and then let's try to submit it. Here we go. Very nice. Okay, so we're able to get success here. So very happy about that. This one went a lot smoother than I thought it would. So happy about that. So let me do a quick whiteboard explanation of the algorithm, and then I'll walk through the code, and then we'll finish it up. Okay, so here we are with the iPad. I'm going to walk through the solution, and hopefully it makes sense as we go through this. So I'm going to walk through the example number 3 from the project, or the Leetcode description. So as you can see, here's the input array tokens that were given. So I've just kind of separated it with lines here so we can keep track of where we're at as we go through. So we're going to start here at I. So I is pointed at 10, and the algorithm is going to go like this. So if we run into an operand, like a number, 10, 6, 9, etc., an actual integer number, then we're going to push it onto the stack with no further questions, because there's nothing we can do about it. We need an operator, like a plus sign, multiplication, division. Those are operators. Those are things that actually perform actions on the operand, right? So if we ever encounter an operator, then we need to pop things off of the stack and compute them, and then we'll push things back onto the stack. So we're using a stack as our data storage and kind of backing data structure for this algorithm. Okay, so some of that might not have made sense. Bear with me. Let's walk through the algorithm, and hopefully it'll make more sense as we go through. You'll see the pattern, and you'll be coding this in no time. Okay, so we are at I is 0 here, right? And since it is an operand, we're going to put it right in the stack, okay? And then move on. So now I is at 6. Push 6 on there. We then push 9 and 3, so on, because we're moving I. Over here, we're just seeing numbers, so we're pushing all those. However, when we get to here, let's say cur now is our current element, is a plus sign, then we need to pop 2 off of the stack, okay? So we pop 2 off. And we need to add them now, right? Because we have a plus sign. So we pop 2 off, and then we add 2, or add 9 plus 3, right? 9 plus 3, because we use the plus sign here. 9 plus 3, that equals 12. So now what do we do with this 12? It is not an operator, right? So we need to push it back onto the stack and use it for further computation. Okay, so let me I'm gonna get rid of all these, okay. And we have 12 now on the stack. Okay, and then we move on. I is now at -11, so -11 we push onto the stack. And now I is at the multiplication part, so here's the pattern again. We pop 2 off. All right, so we pop 2 elements off of the stack, and we say 12 times -11, that equals -132. I might have had to look this up on the calculator. Full disclosure, forgot my multiplication there, but -132 gets put onto the stack. And then we move on to here. I is now at division. So we're at division, so then we say 6 divided by 132, and I had to look this up how the programming language does this. This just equals 0, okay? So then we have I that moves to here. We remove this from the stack. We add 0 here. Okay, let me make sure I'm not getting lost here, okay. And then now I is at the multiplication, right? Let's see, I think I might have made a mistake. All right, I'm gonna backtrack just a little bit here. Okay, so then we were at I, which was the slash. Then we had 6 divided by 132, right? Okay, so this is where I messed up. So, yep, bear with me. We remove both of those. I didn't remove the 6 before, so then it's just 10 and 0. So I went through this before, and that didn't look like it was right. Okay, and then we're at I here, so now we're at the multiplication part, so then we do 10 times 0, so those get popped off of the stack. What does this equal? Obviously that is 0. So then we're here at 17. This is I. 17 gets put here. And then we hit the plus sign, right? So 0 plus 17. We remove these from the stack. Hopefully you're able to see the pattern now. So now we're 17 is on the stack, so we're I there. And then we move I over here. 17. And 5 is left on the stack. We have plus. This is at the very end here. Yay. And we're at 17 plus 5, and that is equal to 22. And then what we do is then we push 22 onto the stack. We finish here, right? And then at the end of our algorithm, we can just return whatever is left in the stack, which should just be one element there. So hopefully that made sense. Let me know in the comments if it doesn't. And hopefully in the code, when you run it, you can debug through it and it'll make sense for you. Okay, so we just did the solution walkthrough on the iPad, so hopefully that made sense. Let's go through the code, and I'll quickly go through it. It wasn't too difficult, at least for me. Hopefully it makes sense to you. All right, so at the top here, the tokens, we need to check if it's null or token length is less than 1. We don't really need to do this actually, but it's always good practice to do it at the beginning of your algorithm, do some data validation, because it does say here it's guaranteed to give a valid 1, so you're never going to get something that's null here. But some Leetcode questions want you to check for this, so always good practice. Okay, and then we need to declare a stack, because that's the core part of this algorithm. It uses a stack data structure. And I cheated a little bit, because how I got to do this problem was through like the explore the stack kind of questions there. So I'm going through all the stack questions. So all the questions they give you, pretty much using a stack. So I knew to kind of use a stack there. So I'm not like a super genius and came up with that. Anyways, we have a stack there, and we're going to go through each one of these tokens, right? So each one of these tokens is either an operand here or an operator, which is plus, minus, times, or divide. So then I grab the current token, and then I do a quick check here to see if it is an operator or not. If it is an operator, then remember from the iPad, we need to pop 2 elements off of the stack. So I pop them off here. The first one I pop off, I named second because that's the second one that we want to add, just the way that the stack LIFO works. I need to pop off the first one and name it second, then pop off another one and name it first, because we want the first to be on the left side of the equation that we're creating, or the computation. Okay, and then I create this compute int variable, and I send it over to this method that returns an int and takes the operator first and second. And you basically have to do a quick switch statement or an if-else structure here to say if the operator is a plus, then let's add them. If it's a minus, then let's subtract them. If it's multiplication, so on and so forth. And then I throw a runtime exception down here. If I don't find a valid operator, that means we've kind of hit a bug there, and it needs to throw an exception. Okay, so then once we compute that, and we've already popped these two off, right? Then we push that compute onto that computed value onto the stack. Great. Okay, and then else, so if it is not an operator, then it must be an integer. So then we say num is equal to integer.value of curs, because they all come in strings, so I need to convert this cur into an integer. So I name that num, and then I push that num onto the stack. Okay, and then this just keeps going through, goes through that whole process that I went through on the iPad. And then at the end, I'll be pushing the last compute onto the stacks. And then at the end here, I just return stack.push. And then boom, I have my answer there at the end. So if you kind of look at this example, you'll kind of just, each iteration, I'm kind of condensing the number down more and more and more until I'm left with just 22. So 22 would be left on the stack here, and then I would return it. So I was able to run this one, and I was able to get it submitted successfully. You see I didn't submit any bad answers, so that's kind of maybe a first for me. So that's why I thought it went smoother than I thought it would initially. So sometimes that happens, which is great. Anyways, I think that's it for the video. I have the link to the GitHub code. I paste this code into GitHub so you can take a look at it, so you can have it for reference. But anyways, thanks a lot. We'll talk to you later.